Thank you. And the next talk will be presented by Dr. Oleksiy Shvets from Pisarzhevskii Institute of Physical Chemistry. The title is Catalytic Properties of Nanocomposites based on metal oxides and hierarchical zeolites in time chemical synthesis reaction.
Good morning, ladies and gentlemen. I'm very glad to have possibility to make a presentation of our results in NANO-2020 conference in this beautiful city. My presentation today about new type of porous, microporous and mesoporous materials, so-called hierarchical zeolites.
Sorry, we need to just a moment. We need to switch to turn on your video.
Mm-hmm. I can start. What is zeolites? Sorry. So, hierarchical zeolites. What is zeolites? Initially, zeolites is microporous aluminosilicate materials commonly used as adsorbent and catalyst. Initially, it was opened as natural minerals, and to this time, there are more than 15 different type natural zeolites. However, the last 50 years, in last 50 years was opened many synthetic approach to preparation of synthetic new zeolites with different structure, different porosity, different size of microchannels. There are more than 215 different structure type. This page from International Zeolite Conference site, and all these zeolites are different in sense of chemical compositions, structure, stability, size of microporous, and of course properties and application. There are many applications of zeolites, such as hydrogen production, radionuclide removal from water, carbon capture, carbon dioxide capture, biomass conversion, and other. But mostly zeolite used as high effective and high stable catalyst in some different industrial process, especially generally mostly in the raw chemistry process, such as cracking, isomerization, gas to liquid distillation, alkylation, condensation, esterification, dehydration, and many others. What is hierarchical zeolites? What is hierarchical porous materials? Professor Schwieger in her review formulated this as two-type hierarchicity, hierarchicity number 1 and number 2. In both cases, in presence of hierarchicity shows that can be some tree of porous which can make better diffusion and better accessibility of surface in such materials, and of course effective center of such materials which located in usually in external surface or microporous. For creation of hierarchical materials can be used a different synthetic approach. There are many methods of preparation, porous materials with presence of mesoporosity, which can use it as transport mesoporous for better catalytic activity and better accessibility of active centers. But one of the, sorry for technical problem, we synthesized more than 50 different structure, different compounds with different structure. For all the structure, there are some character details in end of molecules presents large hydrophobic chain. We tested such materials as template for or so-called structure direction agent in different direction media, aluminum, gallo, boron silicate, tannous, tin, and zirconium silicate. And as a result, we synthesized a few different zeolites, hierarchical zeolites with structure morganite, FI, TW, and beta. Sorry. The structure of these zeolites present in this slide, this zeolite structure slightly different, and especially in context of size of and dimensionality of micropores. The morphology of such materials are different and can be nanosheets, nanorod, or nanoparticle, which intergrows in different agglomerated hierarchical zeolites with large volume of mesoporous, which can use it as transportable mesoporous channels. And of course, with some domination of some surface of zeolites as dominant surface. The type of morphology of such nanoparticle depends from mechanism of formations nanocrystals and depend from correlation between structure of template and chemical composition of zeolite, which can form it in such reaction media. There are two different mechanisms. It's so named capping mechanism in case of covering of by molecule of template, covering of nanocrystal zeolites by molecule of template, or interpenetration. In this case, can be interpenetration of molecules in the micropores of nanocrystals. Depending of mechanism of formation, can be formed nanosheets, nanoparticle, nanorods, or sometimes nanoneedles, nanocrystal, which agglomerated in large porous substance. Absorption properties of such materials is very high. Because in such materials present not only micropores but large volume of mesoporous. Absorption as a term show that presence of developed external surface, some case up to 600 meters per gram. Due to possibility to make the ion exchange of such zeolites can consist from different active centers, not only Lewis acid centers, but also due to ion exchange into hydrogen, into protons. In such structure can be formed protonic acid centers. It's bridged COH groups, which have strength as similar as hydrochloric acid. For determination of strength of acid center as well as type of such acid centers can be used different methods. One of this method is using of some spectral probe, for example, pyridine molecules, which can determine type of centers, concentration, and strength of such centers. Of course, presence of acid centers in zeolites can allow us to use such materials as catalysts in different processes, including some process of fine organic chemistry. As example, I can show some reactions, some catalytic activity of similar materials in some fine chemistry reaction. For example, for preparation new generation of stereoselective catalyst for polymerization in olefine, last year I used ANSA zirconocene, and for preparation of some zirconocene catalysts, need to make very accurate and selective dehydration of brom substitution in the nodes into corresponding indene. Tested different composition of different zeolite with different composition, with different acidity, and can show that in all cases, depending on substrate which need to transform, can be used different zeolite with different acidity, especially with different strength of acid centers, and its results can be reach very high yield of Gewald compounds. The mechanism of some this transformation include formation of diester, and its reason why must be optimal acidity, optimal strength of acid center, because in case of very strong centers, can be some backside process, for example, alkylation or semi-alkylation, with decrease yields of needed compounds. We try to make some correlation between acidity, especially acid centers strengths, and catalytic activity, especially selectivity in this process. For the precise determination of acidity, especially acid strengths, we use a method of potentiometric titration with possibility to exact determination PTA of acid center with presence in zeolites. As we can see from this picture, there are quite narrow fields of optimal acid center strength for achievement of high yield of indene, because in case of more strong centers, we can obtain very large quantity of backside products. In case of less strength centers, we cannot achieve high conversion. Next reaction, it is Gewald reaction. It's a formation of aminothiophenol with different structure, which usually promoted by basic centers. For creation of basic center in zeolites can be prepared different ion exchange form or composite with some oxide nanoparticles, which can show basic activity, basicity, and of course activity in basic promoted catalytic process. We tested different composition, different materials, magnesium, titanium, or thin oxide nanocomposite, or cesium or titanium form of zeolite. And as we can see, can be achieved very high conversion with very high selectivity. For some compositions, the yields of those products can be achieved near the 100%. In comparing different substrate for transformation, we can see the most high yields typical for cyclohexanons or cyclopentanons substrate. Next example of high activity of such hierarchical zeolites into different processes, it's condensation of pigments or annulation of naftols. What is interesting is we can very clear difference between activity of identical zeolites with identical composition and acid center concentration, but with different morphology. For example, nano particle of zeolites usually is more active than nanosheets of zeolites. For zeolites beta, or for example, nanorods of morganite, it's more active than nanosheets for zeolite morganite. And in all cases, this hierarchical zeolite shows more high activity comparing with bulk zeolites. One more process, it is formation of acetals from alcohols and aldehydes. We can see different activity, especially high activity at using of small substrate with formation of diethoxyethane. In case of more large substrate with formation of dibutoxybutane, such activity is lower. However, we can see very interesting dependence of yield of this Gewald substrate, Gewald products, from some superposition of external surface and concentration of acid centers. So there are many factors which influence information of hierarchical zeolites. It is structure of hydrophobic part of organic molecule template. It is C2 element ratio in reaction mixture because it's formate one or other type of zeolites. If nature of hetero elements, pH of reaction mixture, and at favorable condition can be formed different zeolites with high developed external surface, and these hierarchical zeolites can show very high activity and what is more principal, very high selectivity in different fine chemistry process. Thank you for your attention.
Thank you for very interesting talk. So we have only one question in the chat, and I will formulate again from the Dr. Leonid Dolgov. Dear Oleksiy, please comment, did you ever obtain a sort of layered zeolites with such good periodicity of layers, which gives some photonic properties like opalescence in opal photonic crystals?
Oh, okay. If I understand correctly your questions, you talk about formation of nanosheets and some periodicity of layers in these nanosheets. Usually,
sorry, I will not cheap. It's more macroscopic behavior. It's on the large scale, not micro. So could you obtain some periodicity on the large scale?
Usually no. Some periodicity can be present. For example, if we can formate a zeolite with close to sphere nanoparticle, then in this case can be possible some self-organization with formation of some grid from sphere nanoparticle, which self-organizate with quite good ordered mesoporous materials with very narrow distribution of mesoporous between nanoparticle. But some structural ordering of such systems, I think that by direct method without addition of some special composition, special template, I think that it can be possible. Sorry?
Okay, thank you very much. I will have problem with connection. No more questions. Thank you for again for very interesting talk. And
maybe you ask from our phone. Maybe someone request answer.
Hello.
One moment. What we have.
Okay, so some problem again.
Sorry, Blin.
Olena, please.
Why do you use zeolite for fine chemistry? Usually, such reactions at soft conditions.
Yes, I understand. 2 points. First point, of course, a lot of this reaction can be provided in homogeneous media using typical organic catalyst or typical or some substance for reaction. But in this case, very often we can obtain a very large distribution of product, and we will have large problem with elimination of these products from reaction mixture. Second problem is if we transform this reaction in heterogeneous media, we can separate of catalyst by similar filtration and very easy to prepare solution, clear solution with high concentration of gold products. Using of zeolite as heterogeneous catalyst can allow us obtain high yield and low high yield of gold products and low concentration of some side products, and make more easy to elimination of those products from reaction mix. Simply evaporation or concentration and crystallization of product.
Thank you for the question. Dear Professor Leonid Yatsenko, we have two type of questions. One questions you can see in chat, but another type of question is from conference hall. That's why we sometimes will ask our conference hall participants about question to this plenary section. Okay. And
okay.
Yes, please.
No
Please
problem.
I ask you to invite the next our guest.
Okay, thank you, Elena.